Okay, I don't know what happened. Someone left. Okay, can we do a survey? Whoever has a problem with my voice being cutting, can you just type me? Quick survey. 1 minute. 1 second, don't write me here. This is going to be a fiasco. Let me do something. I don't know what is SQ doing. There appears to be, yes, I acknowledge policies, SQ, something. What is going on here? Why is Spring 20 back here? Okay, me. Al-Anud, I'll get back to you in a minute. Hamza. Okay, let me do something. Week 3, please go to Moodle if you can and fill in this very quick survey. I want to see how many people exactly have problems. Voice issues in Sec 21 tutorial. Display vertically. Option 1, big problems. Some problems. No problem. Okay, can you please fill in this survey under week 3, voice issues in section 21, so that I know who has this issue? Okay, book. We will be using this book, the one in green, University Physics Volume 1. This is the prescribed book for this course. We will be using this book and this book only. If I ever don't use this book, I will either give you the slides or give you copies of the pages that I am using from any other book. So far, until the end of chapter 2, we have only used this book, okay, and the slides, nothing else. Some of you have gone to the university bookstore and they have received this book, okay. We are not using this book. We used to use this book beforehand. We are no longer using this book, okay. So this book is very good, very useful. I will even upload, maybe I will try to get permission from the university to upload a PDF copy of this book to Moodle, because it is copyrighted. It is illegal to usually do that. But we are not using this book for this course. Okay, we are using this one and this one only. Okay, let's see how many students have response so far. Three students have a lot of problems. Some students have some problems, and some students do not have problems. Okay. Okay, do one thing. If you are having problems, do this. I know, Fatima, I don't like electronics copies as well. This is why I have actually printed for myself copies. But the thing is, the university has decided for multiple reasons to switch to this book. One of them being that it is easier for students to see this book and study from it, other than coming all the way from wherever you are to pick up books. It's really out of my control. Okay, I will try my best. Okay, if you're having problems hearing me, do this. Go to settings, video, receive, audio only. Do this and see if it makes it any better. Or do this, standard definition, one video at a time. It is an open source book, so you can print the whole thing. Okay, I'm really sorry about the voice. There's nothing I can do. I am recording it, so hopefully okay, let me try something else. I don't think this is the problem, but let me try. Do you still have problems hearing me? Those who are having issues, do you still have problems hearing me? Okay, I'm going to try doing this. I'm going to try using the webcam instead of the professional camera. Hopefully that might fix some of the issues. It gives you a worse image, but that is the best I can do. I'm sorry about that. Okay, so we're covering chapters 1 to 15 except chapter 14 in the book, if you want to print it. Okay. All right, so let's start with questions. Conceptual questions, starting with question number 19, which a few students have asked me about. Calculate the approximate number of atoms in a bacterium. Assume the average mass of an atom in the bacterium is 10 times the mass of a proton. This is one of those problems where we said estimation is going to play a big role. Okay. So this is question number 19 in chapter 1. So chapter 1, question 19. Okay. To solve this, all we need are some really simple numbers that are given in our book. And I'm actually going to go for that. And I'm going to open it here. This one. Okay, so this table in your book on page 22, page number 12, okay, gives you some general numbers that are useful to know. To answer the next question, no, you do not have to memorize these. Okay, over time, you will learn to use them in a very wide range of settings, but you do not have to memorize these. Please do not memorize these. It would be a waste of effort. Okay. Can you see my screen? Okay. So we're using this. Now, how do we solve this problem? The question is, how many atoms in bacterium? What do we know? Mass bacterium equals mass bacterium atom is approximately equal 10 times mass of proton. This is all we know, literally. Okay, that's fine. No need to panic. We will go to our trusty, handy list. Let's go in masses. Mass of a proton, 10 to the minus 27 kilograms. So I'll write it down. Information I have. Mass proton, 10 to the minus 27 kilogram. What else? Mass of a bacterium, 10 to the minus 15 kilograms. So mass of bacterium equals 10 to the minus 15 kilogram. Do we need anything else? I don't think so. This is sufficient to start. Okay. Yes, one way we can do it, Mahmoud, is convert it to moles, but we can do it even in a very hand-wavy way to estimate. If we want a very accurate answer, we'll convert it to moles. If we want a very quick answer, we don't even need to convert it to moles. We can do it even quicker than that. How, you might say? Well, mass of one bacterium atom is equal to 10 protons. Okay, this is the information we have. Mass of bacterium atom equals 10 mass protons. How many atoms do I have in a bacterium? Well, if I know the mass of the full bacterium is 10 to the minus 15, and the mass of one proton is 10 to the minus 27, and each 10 protons is one mass of bacterium atom, I can immediately find out, I can say, okay, my mass of my bacteria is equal to my total mass, 10 to the minus 15 kg. Let me actually write it in words first. Total mass of bacterium divided by mass of one proton. This will give us 10 to the minus 15 divided by 10 to the minus 27 equals 10 to the 12 protons. But we already know here that one atom has 10 protons. So if I divide that by 10, 10 to the 12 divided by 10, I will get approximately 10 to the 11 atoms in one bacteria. Okay, so although at the beginning it looked like a very crazy problem with a lot of difficult parts, what we did is, okay, we know the mass of one bacterium, we know what is the mass of one proton. Dividing one by the other tells me how many protons there is in a bacterium. Once I know that, I simply divide that by 10 to get the number of atoms, because we are told that each atom will have 10 protons in it. When I check the answers, they just need the steps of solving problems in physics. I don't know where you check the answers, or yeah, I don't know. I don't know where you check the answers or who is it that that need. But basically, when we try to solve problems, we need to go through the whole thing, so that we know how to do it should we encounter that in the future. Okay. The question said calculate the approximate number of atoms. So calculate the number is what we did. We actually showed up a calculation. Okay. Next question will be 2 questions after that. Question number 21. How many floating point operations can a supercomputer perform each year? Now, what this question actually means is, I'll open this and then we'll tell you what this means. Chapter 1. Move. Good. How many floating point operations can a supercomputer perform each year? What a floating point operation is simply, yes?
We cannot see your screen.
No?
You close it.
Sorry. Can you see it now?
Yes.
Okay, better. Abdurrahman, yes, we will give you the masses of protons and electrons. Okay, if you need them, we will give you them. Okay. This thing keeps getting stuck. Okay. So how many floating point operations can a supercomputer perform each year? Oh no, I think I copied the wrong question. Sorry. My bad. This is 22. You don't know what a floating point operation is, and you don't need to. Assuming one nerve impulse in the body must end before another can begin, what is the maximum firing rate of a nerve in impulses per second? Now, here's the interesting bit. I am not a biologist, neither are you. And I have no idea how long a nerve impulse is, and I don't even know anything about nerves or impulses or the human nervous system. So whatever we do, we'll be using just simple units and physics and some common sense without knowing any sort of details. Okay. Now, let's take a look at our handy table. Here's something useful. The duration of a nerve impulse is 10 to the minus 3 seconds, so 1/1000 of a second. Okay, so I'm going to write that down. One impulse, 10 to the minus 3 seconds. Assuming one nerve impulse must end before another can begin, what is the maximum firing rate of a nerve in impulses per second? Well, let's see. What is sort of our bottleneck? If we can only send one, then just to be safe, the longest distance in a human body is from the brain up top to the foot down below. Your average person is somewhere between 1.5 meters to 2 meters tall. So I'm going to be using around 1.75. So average person height is somewhere between 1.5 to 2 meters. I'm going to take the middle ground of 1.75 meters. Okay. But what is the likelihood of every single signal needing to go all the way from the top to the bottom? Not many. Yeah. Actually, most of the things we don't feel with our feet, we feel with our hands or with our body. So let's say half the person height, 1 meter average is good enough. So to go from one place to the next, I will need distance of 1 meter divided by 10 to the minus 3 seconds. Okay. Which gives me a rate of approximately 10 to the 3 nerve impulses per second. So about, it's 10 to the 3. 1,000 impulses in 1 second in a human body. Okay, again, I'm not a biologist. I don't know how accurate this is. This is simply a very, this is simply a quick sort of estimation. Zainab 21, Maria المفروض من وين بالضبط؟ I'm not sure. وين الافتراض؟ Okay, these don't always follow the homework questions, by the way. Okay, let's see, Ryan and Ma'an. Okay, so the limitation that we have is that your brain is firing signals, okay, and the rule is your brain can only send a new signal when the first signal has already reached its destination. Okay, so imagine it like a really, really old computer, and if something is happening somewhere, you don't know what's happening elsewhere. Now, you want to figure out what is the maximum rate of signals that the brain can send. Now, there are more than one correct solution here, of course. Depends on how you estimate it. The way I did it is, I said, okay, the normal person is somewhere between 1.5 meters to 2 meters tall. Now, usually, we don't feel with our feet. We feel with many other things. So I'm going to use half the length of a human body. So if I have each signal takes 10 to the minus 3 seconds and a length of 1 meter, 1 divided by 10 to the minus 3, you have 10 to the power 3 meters. 10 to the power 3 signals in 1 second. Okay, as a rough estimate of how many signals your brain can send. Of course, this is not biologically correct because we can feel more than one thing at the same time. If I am putting my finger in something very hot, I will feel this is hot. And if someone else decides to poke me from this side, I will still feel the poke on my shoulder, even though my hand is in fire. Okay. Let's do something more, well, more calculation-y and less guesswork. Let's do question number 27. The following lengths are given in meters. Use metric prefixes to rewrite them in the numerical. So the numerical value is bigger than 1, but less than 1,000. For example, if we have 7.9 times 10 to the minus 2 meters, I want to read it in a number that is easier for me to read. So 7.9 centimeters or 79 millimeters. Okay, it's easier for me than to read the scientific notation. And these are the numbers that we have. So I'm going to copy these into my whiteboard. A, B, C, and D. Okay. Any suggestions? What's the easiest way to write 7.59 times 10 to the power 7? I'm going to write it just like this, so it's easier to read. Suggestions? Micro. If this is 7.59 times 10 to the minus 7, going micro would be a good option. But this is times 10 to the power 7. So if you go to the minus 7, it will give you an even larger number. So instead of 7.59, you will end up with something like 7,059,590,000 micrometers, which is not very useful for you to read. Any other suggestions? Meters, mega, kilometers. Good. All of these are good. Now we can either do it in mega or in kilometers. In mega, this is going to be, if I do it in mega, I am going to get 7.59 megas. No, 75.9 megas. Mega meters. Good. Do we agree on this? 75.9 megameters. Yeah. Okay. No, Kev. So let's do it here. A. 7.59 times 10 to the power 7 meters divided by 1 megameter, which is 7.59 times 10 to the power 7 divided by 1 times 10 to the power 6 meters, you end up with 75.9 megameters. But is this the most useful way to do it? What if I try to do it with kilometers instead? Someone already wrote the answer. Or I can say this is 75,900 kilometers. Now, both of them are, of course, technically correct, but the question asked us for the number to be between 1 and 1,000. So the correct answer is going to be this one, 75.9 megameters. Yes, yeah, exactly. Ma'ad, yes. Okay. What about 0.0074 meters? What would be your best way to do this? Centimeters, millimeters? I would personally put it this way. 0.0074 meters is equal to 7.4 times 10 to the minus 3 meters. The minus 3 here immediately tells me that milli is a good option. Okay, so I'm going to divide it by 1 milli, which is equal to 1 times 10 to the minus 3, and immediately I will get 7.4 millimeters. Excellent. I probably should open the chat here. Give me a second so that I can actually see it as it is happening. A lot of you are answering perfectly, and I'm not able to see it. Okay, here we go. Now I'll be able to see it. Noor, yes, this is what the question wants. The question is giving you some numbers which are really big, which are not easy to process with a human brain. So usually if I tell you the distance between my home and SQU is about 40,000 meters or 40 million centimeters. Sorry, 40 million millimeters. These are not very useful numbers, but the human brain is capable to put it between 1 and 1,000 and understand it really, really easily. So instead of these, if I tell you بين بيتي والجامعة 40 kilometers, that would be much easier for you to understand. Okay, let's try C. 8.8 times 10 to the minus 11 meters. 8.8 times 10 to the minus 11 meters. Nanometers, picometers. Okay. Pico. Good. Excellent. If I do this to nanometers, I will get 0.88 nanometers, which is too tiny for me to understand. But if I try to do it in picometers, I will get 8.8 times 10 to the 11 divided by 1 times 10 to the 15. 10 to the minus, what is pico? Someone help me out. Minus 12. So I end up with 88 picometers. Okay. If you're not very sure where to get these from, in our book we have a really good here we go. On page number 18. The pico is 10 to the minus 12, nano is 10 to the minus 9, and so on and so forth. Okay. And I made a mistake here. Sorry, it wouldn't be 0.88 nanometers. It's going to be 0.088 nanometers. Okay, let's try the last one. D. 1.63 times 10 to the power 13. 1.63 times 10 to the power 13 meters. How do I convert this? TM. I honestly don't know what T is. Tera, okay. Terameters. Yeah, I think that would be a good option. So if I take it to terameters, I will do 1.63 times 10 to the power 13 divided by 1 times 10 to the power 12, and I will simply get 16.3 terameters. Excellent. You're all really, really good at this. Okay. So these are the kind of simple questions you might get on a test or on a quiz. Okay. Very simple, very easy marks to get. All right. Let's try something 40 and 46 in chapter 1. Okay. I was about to do 41, but let's see 40. ما يطلبه المشاهدون. 40, 46. Okay. The average distance between the Earth and the Sun is 1.5 times 10 to the power 11 meters. Calculate the average speed of Earth in its orbit, assumed to be circular, in meters per second. What is this speed in miles per hour? Okay. Let me do it on a piece of paper first. Meanwhile, take a look at question 51 while I do this. Why is my microphone off? Okay, let's do this. The average distance between the Earth and the Sun is something. So what I'm going to do is, just to start with, I'm going to draw my problem. Okay, this is my Sun. This is Earth. And the average distance here is 1.5 times 10 to the 11 meters. I want speed of Earth. Okay, this is fine. What is the definition? Oops. What is the definition of speed? Speed is the total distance traveled over the amount of time it takes to travel in it. Yes? Okay. The speed, V, equals distance over time, what is my distance and what is my time? My distance is not the straight distance because the Earth actually goes in a full circle around the sun, right? Because they want average speed in orbit. So my distance is actually for a circle of 2 pi times 1.5 times 10 to the power 11 meters. Okay, the full length of the circle, the circumference. And oops, what just happened? Okay. And the time it takes Earth to go this distance is 1 year. And this is something typical of some problems of physics. You don't get all the everything in the question itself. So in questions like these, where they tell you orbit, you are supposed to figure out that, okay, orbit means Earth going around the sun. We go around the sun once every year. So my time is going to be 365 days times 24 hours a day times 3,600 seconds in each hour. So day, hour, second. Okay. And the number we get is 2 times pi times 1.5 x 11. We get around 9.424 times 10 to the 11 divided by how many seconds are there in 1 year? 356 times 24 times 3600. That's a lot of seconds. 30758,400. And my answer is going to be 29,886 meters every second. Yes, exactly, 29885.7. Okay. So I have used these two as an exact number, as an exact number, as an exact number. This was to two significant figures. So to two significant figures, this is going to be 30,000 meters per second to SF. Mazen, yes, of course, this is extremely important. Okay, this is what all of physics is about. Okay, we need to figure out how to solve problems. Actually, the very definition of what we do in physics is how to solve problems. Minuane 2 pi, because we're going in a circle. So the distance taken is the circumference of the circle, 2 pi r. So what the question is telling us, the distance between the Earth and the sun is this much. But what we're actually going is not in a straight line. We're going in a circle with this radius. Okay, the other question requested was number 46. I need to go back. Chapter 1. Okay, chapter 1, question 46. Oh, sorry. 40. What is the speed in miles per hour? I need to convert this to miles per hour, and I honestly don't know how many miles are there per hour. I don't know it off by heart. If I needed to, I would actually go and okay, here we go. Someone told me 1 kilometer is 1.609 miles. Okay, so now that I know what is it meters per second, 30,000 meters per second, 2 miles per hour. I'm going to write it 30,000 meters per second like this. So to go from meter to mile, what do I need to do? I think this is the other way around. 1 mile is 1.609 kilometers. So I need to, if I have X meters, and this is in kilometers, yes, times 1.609 divided by 1000, or divided by 1.609. I think divided by 1609, divided by. So we divide, not multiply. So I will go from meter first to kilometers. So I'll divide by 1000. Okay. Multiply by 1000 divided by 1.609, like this. And the seconds, I need to go to an hour. So I will divide by 60 for minutes, another 60 for seconds. What do I get? Per hour. Someone tell me if you did this and you got it correctly or not. I have no idea what just happened to my screen. It just went crazy. Okay, so I get 5179.2. Someone else gets 67,000. Okay. So can someone tell me what did I do wrong? Why am I getting a number which is different than the correct answer?
Doctor, as in 1 mile, 1609 meter.
Yes, correct.
We shouldn't convert meters to kilometers and then convert it to mile. We can directly convert it.
Yes, we can do that. But the reason I did it this way is because we don't always remember the exact conversion. If you know it directly, 1609, you do that directly. Same as from, for example, from hour to second. I know that I just go multiplied by 3600. But if you forget that, you can do times 60 times 60.
Doctor, your screen is not viewing, so?
Yes, I'm having a problem because I'm using two screens and it's disconnecting. Let me put it back on. Ah. Keeps changing. Okay. So where did I go wrong? My answer was 30,000 divided by 1609 and then divided by okay. Someone else gets 5179. So I have done something wrong. The correct answer is 6.7. I have done something wrong. The question is, what have I done wrong?
Doctor, should we multiply by 1000 or divide because we have already meter?
So I have meter and I was using the conversion 1.609 for kilometers. This is
Doctor?
why I multiplied. Yes?
And maybe you should multiply with 60 and 60, not divide.
Multiply, not divide.
Yeah.
لازم تضربها في 60 60.
اوكي وانا قسمته 60 على 60.
Yes.
ايوه.
Okay. So I made two mistakes here. Okay. I made two mistakes here. My first mistake that many of you did not notice, actually one person already noticed, okay, is that I used 30,000, which is what? Which is the rounded figure, correct? And what is the number one rule we said in last week's lab? We do not round when we are doing calculations. We only do rounding in the very, very final answer. So this was my first mistake. I should have used 29886 meters per second. Okay, this was my first mistake. I should not have used the rounded off value. The second mistake is I tried to do the entire, this is a long conversion, and I tried to do it all at once, which meant I got confused and I made a mistake somewhere. So let's do it one by one. 29886 meters per second, let's make it miles per second. So we divide that by 1609 and we get 18.645. 18.645 miles per second. Now I take it from second to hour, I multiply it by 3600 and I get actually this is still wrong. 574. I get 66867.4 miles per hour, which is approximately 67,000 miles per hour to two significant figures. Okay, if I try to do it using the figure of 30,000, the rounded off figure, what do I get instead? I will get 67,122, which is incorrect. Okay, so be careful. Don't make the same mistakes that I make. Next question. Number 46. Light travels a distance of about 3 times 10 to the power 8 meters per second. A light minute is the distance light travels in 1 minute. If the sun is 1.5 times 10 to the power 11 from Earth, how far away is it in light minutes? Any ideas? I will do this. 1 Sorry. Speed of light, 3 times 10 to the power 8 meters per second. Distance, 1.5 times 10 to the power 11 meters. And we want the time in light minutes. العنود أيوة خطأ. فقط نقرب في نهاية الحل. إذا استخدمنا التقريبات في الوسط, we will end up with a very different answer. Okay, never do that. Al-Ayham 8.3, you are correct. I haven't done the calculation yet, but I know for a fact that that is correct, because we know that the light takes 8.3 minutes almost to get from the sun to Earth. Okay, so time equals distance over velocity. My distance is 1.5 times 10 to the power 11. My velocity is 3 times 10 to the power 8 meters per second, which is equal to 1.5 x 11 divided by 3x 8, 500 seconds. We want it in light minutes, so we divide that by 60, and we get 8.3 minutes. Okay, this one was nice and easy. Let's do our last problem on this chapter and then move on. #51. Dimensional analysis. Consider these physical quantities. And we want to know whether each of the following equations is dimensionally consistent. Well, let's start. A, v squared equals 2as. Let's take a look at the unit. Units of v squared would be equal to length squared t to the minus 2. Is it equal to the units of 2as? Let's take a look. 2 doesn't have a unit. The unit of a is lt to the minus 2. And the unit of s is L. So we end up with L squared t to the minus 2 equals L squared t to the minus 2. This one is good. We don't have a problem with it. Perfect. We go to B. Let's see if B is okay. Vt squared. Oh, sorry, forgot the s. S equals Vt squared plus half At squared. Let's check the units. S is in length. So whatever the other side is should be also in length. V is Lt to the minus 1. T squared as well. T squared. And what is this? LT, correct? Now I don't even need to continue to do the rest of the problem because I already know this equation is not correct. I cannot have L on one side and LT on the other side. So this is wrong. Let's see C. V equals S over T. Unit of V is equal to L T to the minus 1. Units of S over T is equal to L over T, which is LT minus 1. So this is good. Last one, T. A equals V over T. Unit of A is LT to the minus 2. Okay, someone already said yes, correct. Unit of V over T will be equal to L T to the minus 1 over T equals LT to the minus 2. These two are equal. This is also okay. So only B was incorrect. Is the idea of dimensional analysis now good with you? Yes? Okay. So I will get out of here. I will rename this to tutorial 1, chapter 1, so that I can share it later. Okay. Any other questions in chapter 1 you would like me to tackle before we go to chapter 2? No. Okay. Oh. 84 and section 1.5. 1.5 is estimates and Fermi calculations. Okay, I'll do one of each. I'll do 84 and I'll do Fermi calculations. Let's first take a look at 84. Where's 84? Oh, it's an additional problems. The sides of a small rectangular box are measured to be 1.8 plus or minus 0.1 centimeters, 2.05 plus or minus 0.02 centimeters, and 3.1 plus or minus 0.1 centimeters long. Calculate its volume and uncertainty in cubic centimeters. Okay, this is actually a very interesting problem, which you might face later on in labs, but I'm going to do it anyway. Uh, 54. Is 54 in your course plan? No, good. Because we are not yet doing deep calculus, so we don't need to do 54. Okay, 84. The sides of a small rectangular box are measured to be this. Calculate its volume. Okay, first thing first, how do we calculate volume of a box? Length times width times height. So far, so good. Volume equals length times width times height, which is equal to 1.8 times 2.05 times 3.1, which is equal to 11.439 centimeters cubed. I haven't rounded yet. Okay. Now the question is, what is the uncertainty in cubic centimeters? Now the confusion is because we have these. Let me check something in your book. Okay. Propagation of error. Is propagation of error included in your book? Okay. There are more than one way to do this. Okay. Experimental physics, we do it a bit differently. Your book has another issue. I'll show you 3 different ways to deal with this. One way is to simply say, well, 2 significant figures, 3 significant figures, 2 significant figures. So I am going to 1.1 formula should apply. What formula is 1.1? Yeah, which formula is this? 1.1? Example 1.1? Equation 1.1? Which 1.1? Page 30. There is no 1.1. Ah, method of adding percents. Yes. Okay. So, method 1 is to simply look at significant figures, okay, and say this least here is 2 significant figures, so it's simply going to be 11 centimeter cubed. Okay. Now this is not useful in our case. Okay. The other method is to use the method with which your book calls adding percentages. Okay. So you have 0.1 out of 1.8, 0.02 out of 2.05, and 0.1 out of 3.1. If I look at percentages, 0.1 out of 1.8 0.02 out of 2.05, and 0.1 out of 3.1, I get 0.1 out of 1.8. This is 0.06%. 0.02 divided by 2.05. This is really, really tiny. So this is almost 0. It's 9.8 times 10 to the minus 3. 0.1 divided by 3.1 is 0.03%. If we add all of these up, we get 0.03 plus 0.06 plus 9.86x minus 3. We get almost 1.1%. Okay, 1.1% times our answer. 1.1% times our answer, 11.439, will be 0.13. So I can write 11.439 plus or minus 0.125829. And then since the least I have is 2 significant figures, okay, I can do is 2 significant figures, 1.3, 0.13. I do this. Okay. Noor, the point of this is whenever you take a measurement, there are some uncertainties in it. Now, in these kind of calculations, it's sort of, childish and not very useful. But 11 cubic centimeters is wrong, is not wrong, Mazen. The answer is correct, but it doesn't have the plus or minus in it. Okay, see, we don't have a plus or minus in it. So we are not actually solving the problem. Just using significant figures doesn't solve the problem. Okay, Noor, so let's say you decide to become some sort of engineer. Okay, now whenever you want to do a calculation, how much steel do I need? Or say you are not from College of Engineering, you want to do a budget of something. Okay, you always need to leave some sort of buffer zone for you, okay, just in case the calculation goes wrong somewhere. Okay, or because my measurements are not entirely accurate. I'll give you one example, physical example, in the world of engineering. Whenever we are building a house or a building, one of the things we need to do is to bolt some really big screws and steels. They're called corner bolts, I think. Okay, and steel structures. Now, when you do the calculations for your shear load, stress load, that kind of thing, you need to bear in mind that the maximum allowed when you are doing the actual installation to build your house is plus or minus 2 millimeters in the location of that beam. Any more than those 2 millimeters, and you have a big problem as soon as there is something windy or really heavy rain. Which brings us back to these sorts of calculation. When I do the calculation for the location, this bit of mine, I need to have data that is accurate enough so that this bit of mine is not more than plus or minus 0.2 millimeters. Okay, this is the point of this kind of calculations. Okay, now there are other methods to treat errors. One method is to look at called sum of squares, sum of addition errors, standard deviation, but this is too advanced for this, for chapter 1 of the course, so we'll leave it. Okay. The last question is we're going to do from this chapter is someone wanted to do some sort of Fermi calculation. Okay, what are Fermi calculations? 1.5. Let's do number 65. Looks interesting. Okay. A floating point operation is a single arithmetic operation, such as addition, subtraction, multiplication, or division. A, estimate the maximum number of floating point operations a human being could possibly perform in a lifetime. So let's start with that. Who asked me for this? Al-Anud, section 1.5. Let's do an example. Al-Anud, you here? Help me out with this, okay? What do we need to estimate the maximum number of floating point operations a human being could possibly perform in a lifetime? Well, let's break it down. What do I need as a human to be able to do math? I need to be alive. Good? That's the first important thing. If I am dead or not born yet, I cannot do any math. So rule number 1, be alive. Okay. Rule number 2, Noor said, have a brain. That is good. Also, I will add, have a usable brain. So as soon as I am born, I have a brain, but I cannot really do any math. What is the easiest of these 4? Add, subtract, multiply, or divide. What is the easiest of them to do? To add. Perfect. Okay. At what age approximately did you start adding? Simple addition. Okay. So 1 + 1 = 2. Age of 4. Okay. Let's start at the age of 4. Okay. So useful brain for add, start at 4 years old. Okay. And we forgot a bit about the be alive part. What is the average age of a human being? 80. Okay. Let's do the average age of a human being. Yeah, okay. Medicine and everything is now very good. So people usually end up living around 80 years. So I would say 80 years. Okay. Which means I have a total of 76 years. Okay. I have a total of about 76 years of useful time to add. Okay. Now, here is where Fermi calculations start becoming really interesting. Okay. Now, when I say estimate operations could possibly perform in a lifetime, we need to be realistic, right? Now we have 24 hours a day, but I cannot stay 24 hours awake. Yeah. If I am a really, really, really healthy person, okay, I will be asleep for 8 hours a day. give or take. Okay, so 24 minus 8, 16 hours. Now, of these 16 hours, I will need at least 2 hours total to eat and go to the toilet. Good enough? That's 14 hours. As a normal human being, okay, let's say I am someone who works all the time, I'm a workaholic, okay, let's take, out of 14 hours, I will take 2 hours away because I would want to speak to other human beings and not go crazy. Okay, so actual working hours will be about what? 12? 12 hours per day. So this ties in with my 76 years. Okay, so my 76 years are not the full 76 years. It's actually 76 years divided by 2 because I'm only using half my day. Okay, so half the number of years. 76 divided by 2 is 38 years. Good? So far, so good? Okay. Now let's take the simplest, absolute simplest addition. 1 plus 1 equals 2. 2 plus 2 equals 4. 3 plus 3 is 6. 4 plus 4, 8. 5 plus 5, 10. Yeah? How long does it take me? Anyone has a stopwatch? And the clock. Let's see. Here we go. Stopwatch. 1 plus 1, 2. That's about 1.1 seconds. Let's try again. 10 plus 10, 20. 1.7 thing. So on average, say I need about, to do the simplest operations, just limit ourselves from 1 to 10, I need around somewhere between 1 to 2 seconds. Yeah. So if you ask me 20 plus 20, 40, let's say 1.5 seconds average between 1 and 2. Yeah, 1.5 seconds per operation. I have 38 years of life, okay, up until the exact moment I die, and at 1.5 seconds per operation. So now I can do 38 years times 365 days times 24 hours times 3,600 to take it all the way to seconds divided by 1.5 seconds, which means how much? Let's see, 38 times 365 times 24 times 3,600 divided by 1.5. I can do approximately kilo mega 799 mega 798.9 798.9 mega operations. This is the number that I end with. How long would it take a supercomputer to perform that many floating point operations? If we go to that lovely thing of ours, time for a single floating point operation in a supercomputer is 10 to the minus 17 seconds, right? So if I take this many operations, 798.9 mega, and I say it takes, how much did we say? 10 to the minus 17 times 10 to the minus 17 seconds. It will take a computer This is not going to be nice. 7.99 times 10 to the power minus 9 seconds, which is 8 nanoseconds. Not a very cool number. Really knows how to put our humans in place. Okay, so this is an example of a Fermi calculation, and we used some very common sense numbers. Okay, we did not bring anything from books or just common sense. Now, here's an interesting thing I want to do before we move on to chapter 2. Okay, we ended up with 798.9 mega operations. I am actually going to go to Google I will go to Google and I will actually copy paste that question. Without all the addition, just estimate the maximum number of floating point operations a human being can possibly perform. Let's see, we have Slater, Chegg, Numerate. These are very, normal websites for students to take a look at. Let's see what other people who have been asked the exact same question have answered. Ready? See, they have done something similar. Average age of a human, number of calculations per minute. There is no human that can perform calculations 24 hours. So how many hours that is taken to perform these operations? Now, here is the interesting bit. Look, you have taken somewhere that they have taken number of calculations per minute to be somewhere between 10 and 50. So 10 calculations per minute, okay, means they are taking about 6 seconds per calculation, and 50 calculations per minute means they're taking 1.2 seconds. We took 1.5. Okay, but then again, there is no human that can perform 24 hours. They took it between 10 to 15 hours. We took 12 hours. Okay, and they ended up with 10 to the 9 calculations per life and 10 to the minus 8 seconds for the computer. What did we end up with? 798.9 mega operations. 798.9 divided by, times 1 mega. So this is times 10 to the power 3 times 10 to the power 6. What did they end up with? Times 10 to the power 9. So we ended up with 0.8 times 10 to the power 9, which is almost 1 times 10 to the power 9, and they ended up with the exact same number, 10 to the power 9. Although we had totally different ways of doing it. Here is another thing. Okay, I'm not happy to pay. Sorry, no. Okay. This is another website where they have ended up with around 10 to the 9 operations. And see, this is the strength of this is the sort of strength that these kind of calculations do, is because we take some very common sense numbers. Okay, so although the solutions we get are not perfectly accurate, on whole, they are rather very well accurate. Okay, let's take a 5-minute break because I have a headache and I'm pretty sure you also have a headache. And then we will do 3 questions from chapter 2 and I will be done unless you have other questions. Okay, so let's take a short break. Okay, let's continue. So, yes, how to solve problems, conversion of units, estimates in general. That's it. That's it for chapter 1 is just the foundation for everything else we're doing. Okay. Chapter 2. We'll start with question number 29. A delivery man starts at the post office, drives some number of kilometers north, then west, then northeast. Okay, let's copy this and then do it properly. Okay, here we go. A delivery man starts at the post office, this is here, drives 40 kilometers north. So 40 kilometers. Then 12 kilometers west. Never eat silly worms. That way. 20 kilometers west. Then 60 kilometers northeast. I'll use a different color. And this is obviously a bad choice of location. I did not read the question in advance, so I'm going to do this. Okay, then 60 kilometers northeast. Northeast means exactly at an angle of 45 degrees. And finally, 50 kilometers north to stop for lunch. Again, this way, 50 kilometers. Use a graphical method to find his net displacement vector. Okay, now what I drew was not particularly accurate because it is not to scale. Okay, if this is 40 and this is 20, then 60, let me redraw this. Let me draw it to scale-ish. So I'll do 4 lines for 40, half the length for 20, then 60 is going to be something like this, and then another 50 would be all the way up to here, which means that my net displacement will be this. Okay, now the question says use a graphical method. I hate graphical methods. It is impossible to do graphical methods on a screen this way. It is impossible to do it usually in an exam unless you have a very good set of graph papers, protractor, manqala, and that kind of things. So I am not going to be doing it using a graphical method. I will be doing it using the component method. Okay. Yes, I'll use components. Okay, so let's do them. First, he went. This is only 2-dimensional. Okay, so I will only use I and J. First, he went 40 in the I direction. Then he went, no, sorry. First, he went 40 in the J direction, north. Then he went, yes, J, sorry, my mistake. Then he went 20 in the minus I direction. Or if you want, you can write it as minus 20 in the I direction. Then he went 60 kilometers at 45 degrees because they said northeast, which means exactly 45 degrees. Then he went 50 in the J direction. I will take number 3 and make it into components. This is hypotenuse, this is opposite, this is adjacent. Yes?
How you do know the angle is 45?
Because they said northeast. So you have north, east, south, west, and when they say Shamal al-Sharqi, northeast, what it means is exactly northeast, exactly in between. So it means this is 45 degrees. Okay. So whenever you say northeast, northwest, southeast, southwest, it's 45 degrees. Because it's exactly in the middle, between north and east. Yeah? Okay, I will resolve it into components. My j direction is this, my I direction is this. I have opposite here, so this is going to be sine. I have adjacent here, so this is going to be cosine. So in the j direction, I will have 60 sine 45 degrees. In the a direction, I will have 60 cosine 45 degrees. Now sine 45 and cosine 45 are actually the same thing, I think. Yes, they're the same number, square root of 2 over 2. Okay, so 60 times sine or cosine 45 means I will have 42.43 in either direction, j and I. Let's find the net displacement vector. It's 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. Good. So I have 40j minus 20i plus 42.43j plus 42.43i plus 50j, which is all the j's together, all the i's together. So 40 plus 42.43 plus 50, I will get 132.43 j, and I have minus 20 plus 42.43. Do I have anything else in I? No? No. So that is 22.43i. Now, if I want to know the angle, and if I want to know the displacement vector, what I will do is magnitude of displacement is equal to 22.43 squared plus 132.43 squared, square rooted. I get 134 kilometers, and my angle will be tan inverse of 132.43 over 22.43. Sorry, over 22.43. Tan inverse about 80 degrees. Okay, no drawing, no protractors, no headaches. So far, so good? Anyone has problems with this question? Ooh. Yes. When do you add 180? It really depends on the question. Okay, there is no clear rule when do you add 180. It really depends from where do you take the angle. Okay. So most times you will not need to add 180. If you have specific examples where you need to add 180, email me with those and I will get back to you. Most times you will not need to add 180. Okay. If you go southeast, okay, if they tell you, say for example, the problem says instead of northeast, they say southeast, like this, right? Well, say it has gone 60 kilometers southeast like this. Instead of adding 180 or everything, I will simply take this 45 angle and redefine my problem. Now, the x-axis will become sine, and the y-axis will become cosine. But that's it. I'm still using 45 degrees. I just simply changed which angle am I looking at.
دكتور،
أيوة.
هو في قاعدة لهم اللي هي إن في first quadrant all of them are positive, second quadrant the sign is positive and the remaining are negative, third quadrant only the tan is positive and the remaining are negative, and the fourth quadrant cosine is positive and the remaining are negative. So it's depend on the x's and y. Here in the first quadrant x and y are positive. In the second quadrant y is positive, x is negative. In the in the third quadrant both of them are negative, and the fourth is x is positive and y is negative. So it's depend on the values of x and y.
It depends. It very much depends on the values in x and y, and also you need to very clearly define. So I actually made a mistake here, which thankfully you have actually notified me too. I said my angle is 80 degrees, right? 80 degrees from where? From north, from east, from south, from west? 80 degrees from where exactly? Manrasi? It doesn't work that way. Yeah, I need to specify 80 degrees from where. So I actually need to say 80 degrees counterclockwise from plus x-axis, or from plus I. So when I say it at 80 degrees, I mean it is like this. And this is my 80 degrees. So thank you for notifying me to that.
Doctor, and moreover, in the first quadrant, it is we take the value at is it, and the second quadrant we take the value 180 minus the value, and the third quadrant 180 plus the value, and the fourth quadrant 360 minus the value. So I think Al-Unud was asking about that.
This is correct if you memorize, if you only choose one of the lines. So you have north, east, south, west, صح؟ أربع خطوط. If you decide as a rule أنا فقط وفقط راح أختار أنه to define all my angles from north, from the positive y. In that case, yes, you need to add 180 or subtract from 360 and all of that. But the way I have done it in this problem is I did not decide. See, actually, I defined my 80 degrees from here, not from here. So these rules would not apply. Yeah. The easiest way always is to, rather than to memorize, I add 180, I subtract from 360. Personally, I don't like memorizing rules because it gives me a bad headache. There are too many rules. By the end of this course, you will have more than 200 equations maybe. If I try to memorize all of them, it gives me a bad headache. So what I do is, for me, it is much easier to define. Say, for example, it goes like this, and this is my angle, okay? Rather than taking whatever angle this is and then adding 180 degrees and then defining it to be this angle, yeah, what I do is I simply take this angle and I define it to be from the negative y-axis. خلصنا. ولا يحتاج احفظ انه plus 180 ولا احفظ انه 360 minus. انا اخبركم انه انا ماخذه والله 20 degrees from this line. حسبوها بنفسكم. Yeah. Page 61. Where is my book? يا إلهي، هذا الكتاب يحب يتكلم واجد. العنود Ignore everything on page 61 and remember what I told you now. It's much easier than to memorize. Because page 61, I just read it and it gave me a bad headache. Okay? They are trying to force you to go through to always start measuring from positive x in a very specific action. Okay? You don't need to be forced to do that. Okay? You can choose whatever you want. It's like me asking you, telling you, اشرحي لي وين دوار المعبيلة. Okay, you are free to choose. دوار المعبيلة كذا كيلو من روي، ولا كذا كيلو من مدينة سلطان قابوس، ولا كذا كيلو من جامعة السلطان قابوس. I don't need to force you أنه listen. Whatever direction I need to ask you, okay, whatever question I need to ask you, you have to answer me from a specific location. There's no point in me doing that. Okay. Nahla quest for 56 and Nasira wants 28. Let's see. For vectors given in the following figure, use graphical method. There is no way I can do it on a computer. I'm sorry. Okay. There is no way I can do question number 28 graphically because it literally requires a graph paper and doing it with a protractor and all of that. Okay. It's just pointless. It's just pointless. Trust me. I've been doing vectors for many, many years now. The graphical method is just a pain. Okay. 56. Let's do
Doctor?
36. Yes?
I have only a question about 52. In the solution guide, they add between cosine and sine as يعني they add the cosine with sine. They don't add sine with sine and cosine with cosine after getting the vectors.
I will take a look. I don't know the problem. Question number 52?
Yeah.
Because it depends on the angle. See, some of them, the angle is from the positive x-axis. Some of them, the angle is taken from the negative x-axis. Remember when I told you never memorize which one is sine, which one is cosine?
But doctor, see, even if while solving part A, I don't understand that.
Okay, we'll come to 52. Let's first do. Okay, we'll do 3 more questions. We'll do 52, 56, and 66. Okay. 52. Assuming the positive x-axis is horizontal to the right for the vectors given in the following figure, use the analytical method to find the following resultants. A plus B. Okay, this is way too many. I'll do one of them. I'll do A plus B. Okay. A plus B, to find the resultant, you will do A cosine 30 plus B cosine 30, plus B cosine 53, and A sine 30 plus A sine 53. Yeah?
Doctor, you are writing something in the whiteboard? Nothing is
No.
viewing.
No,
okay.
not yet. Okay, so how do I do this? Okay, let me do something. واحد. Okay, here's our problem. Yeah? A plus B. We will have A in the I and in the J direction. In the I direction, this is my angle, this is opposite, this is adjacent. The one with the O is a sine, the one with the A is a cosine. Okay, so in the I will have 10 cosine 30. In the J, I will have 10 sine 30. B. I will do this for every single one of them. B in the I,
Cosine.
I will have 5 cosine 53. And in the J, I will have 5 sine 53. For C, this is my opposite, and this is my adjacent. Okay, so again, for the I,
Cos.
I'll have 12 cosine 60. For the J, I will have 12 sine 60. For D, opposite. Yes, correct. Adjacent, and this is my angle. So in the x-axis, I will again have 20 cosine, and in the j-axis, again, I will have 20 sine. For F, they're all cosine and sine.
Doctor, my question is, while adding A plus B, they are adding cosine with sine and sine with cosine
Where did you see this?
in the solution guide.
Let's see. Because I honestly don't know. Physics for solution manuals, chapter 2. What is this question number? 52?
Yes.
There is no solution for 52. Solution in a 51 or 53? Am I missing something?
It shows with me. I send it now with email and you can view it.
1 second. Let me see. I haven't received a thing yet. Let's wait. Noor, you can bring it from the x-axis or any other axis. It's entirely up to you. Okay. Did you send the email to me? I still haven't received anything. Yeah, Saud, because it's minimized, that's why. Okay, until that email shows up, I will go to, actually, let me see something.
Doctor, the email is sent.
It will take maybe some time. Okay, there we go.
They are adding sine with cosine and cosine with sine. I don't know why.
This is not from the manual. This is from another website.
No, doctor, it is from the Slader.
Yeah, Slader is another website. It's not the official manual. But let me check nevertheless. Tan cosine 30 degrees plus 5 cosine 53 degrees. Tan sine 30 plus 5 sine 53. Eh? For A plus B, they have made a mistake in the solution manual. See, all the rest, they're adding the i's with the i's and the j's with the j's. For the first one, they have made a mistake in the solution manual.
That's why I'm asking you.
Yeah, no, they have made a mistake in the solution manual.
Okay, thank
And
you.
on that website. Aywa, this is correct. 11.7 plus 9, this is correct. Okay, good. So the fact that we're able to spot mistakes in other people's work is actually excellent news, because that tells us that we're actually understanding what we're doing. We're not just bulldozing across without understanding, which is, believe it or not, for me, it's a really, really good news. Okay, so we finished question 52. Now we go to question number 56.
Doctor,
Yes.
question number 56. Something is missed in it, I think.
Let me see.
Because it's this dash, F dash, and then the question.
No, there's nothing missing. The person who typed this textbook, the person who typed this textbook used justify, and there isn't enough text. So it looks really, really ugly. I'll show you now. So what this question says, if D equals 6i minus 8j, B equals minus 8i plus 3j, and A equals 26i plus 19j, find the unknown constants A and B such that AD plus BB plus A is equal to 0. There's nothing missing. It's just that because there isn't enough text here, it's putting extra spaces. Okay, so A. So I will use this notation. This might be the first notation. This might be the first time you see this notation. It's the same as writing matrices. So basically, whatever is up on top is I, whatever is on bottom is J. So we have 6. Oh, no, sorry. For A, we have 26, 19. For B, we have -8 plus 3. For D, we have 6 and -8. So we have AD plus BB plus A is equal to 0. So 26A minus 8B. No, this is confusing. Sorry. So 6A, because D is first, plus, nope, minus 8B plus 26 is equal to 0. Oh, the computer is dying. And I have minus 8A plus 3B plus 19 is equal to 0. You have a set of two simultaneous equations. You add all the i's and you add all the j's separately, and you have a set of two simultaneous equations. Okay, I will substitute one in the other. Okay, I will do 6A minus 8B equals minus 26, which means A equals minus 26 plus 8B divided by 6. So I will get minus 8 minus 26 divided by 6 plus 8 divided by 6B plus 3B plus 19 equals 0. This is going to be a fun mathematical equation. Minus 8 times minus 26 is equal to 206 divided by 6. That is not a cool number, 34 and 2/3. So I'll have 34 and 2/3 minus 10 and 2/3 B plus 3B plus 19 is equal to 0. 34 and 2/3 plus 19. 19 plus 34 2/3 is equal to 41 and 2/3. We'll have 41 and 2/3 minus 7 and 2/3 B is equal to minus 19. Take this here, bring that there. So 41 plus 19 is equal to 60. So I have 60 and 2/3 equals 7 and 2/3 B. I'll cancel the 2/3 off. And that tells me that B is equal to 60 divided by 7. Okay, so I get 8.57 for B. I substituted back here for A, and I get A is equal to minus 26 plus 8 times 60 divided by 7 divided by 6. You get a number. Yes? Did I make a mistake somewhere?
Yes. From where you bring 41?
41 was 34. Did I make a mistake somewhere? I think I made a mistake somewhere trying to do it very quickly. Sorry, I made a big mistake. My bad. I shall delete everything and start over again. So 34 plus 19 is 53, actually. So I have 53 and 2/3 minus 7 and 2/3 b equals 0. 53 and 2/3 equals 7 and 2/3 b. This and this are cancelled out, which tells me b is equal to 53 over 7. Is it now right? Did I make another mistake? No? And a will equal to minus 26 over 6 plus 8 over 6, 53 over 7, which is minus 26 over 6 plus so 5.76. Is this correct? Did I make a mistake somewhere? No? صح غلط maybe. Who agrees, who doesn't agree?
لكن دكتور أول شيء بالآي والجي كيف حددت إن تكون 6A وسالب 8B؟
هنا 6i minus 8 minus 8 زائد 3 26 و 19 في السؤال نفسه.
لا أيوه هنا في أو بداية الحل لا.
ترى هو يقول انه the sum of vectors equals to 0. When the sum of vectors equals to 0, it means that the sum of their components is also equal to 0. So I just summed all the i's وحدهم all the j's وحدهم.
تمام.
تمام. One second. Let me look at something.
دكتور.
ايوه.
مثلا ارجع شوي لو سمحت.
تمام.
شاشة منطمسة أنا عندي سودة.
Okay, it's open now again.
شوف مثلا الآي 6A minus 8B زائد 26.
ايوه.
إيش ما سوينا سالب 8A مثلا يعني؟
لأنه هو قال لنا AD زائد BB زائد A يساوي 0 صح؟
أيوه.
انزين ف A ضرب الآي مال الدي، ايش الآي مال الدي؟ 6.
أيوه.
صار 6A.
صح.
زائد B الفيكتور B. ايش الآي مال الفيكتور B؟ سالب 8. فصار سالب 8B. زائد A. A هنا 26. زائد 26 يساوي صفر. هذول كلهم I. ونفس الشيء بالضبط for vector for the J components.
اها تمام.
Yeah.
ايوه مشكور دكتور.
Okay. Now we go to the. Okay.
دكتور هذا طبعا بيكون موجود في القناة لا؟
I will try. مفروض أيوة بس it will be private not public.
يعني
So only for section 21.
يعني تنزل هذا
اللينك بيكون موجود على مودل إن شاء الله. أيوة.
تمام دكتور مشكور.
Okay. اليمامة أقواس كبيرة. This is a different way of writing vectors. So for example, we haven't learned this yet. Okay, we will actually learn this tomorrow. Okay, in tomorrow's lecture. But say for example, you have vector A, which is 2I plus 3J plus 4K. مثلا. Another way of writing vector A is doing this long matrix-like thing and writing 2, 3, 4. Okay, it's just another way of writing it. It's neater. Okay. Final question, number 66. وينه 66 هذا؟ Show that the force vector, this, is orthogonal to the force vector, this. Okay, what does this question actually say? We have one vector and another vector. They're saying show that they're orthogonal. Does anyone know what does orthogonal mean? Anyone? عمودي? No. متعامد. Excellent. Okay. It means that they're at 90 degrees. If two things are orthogonal, the angle between them is 90 degrees. So the easiest way to show this, okay, the easiest way to show this is, remember what was our, we want to prove they are at 90 degrees, right? Remember what our definition for the dot product was? We said A dot B is equal to A, B, what?
X.
Cosine or sine? Do you remember? Cosine.
AB cosine.
AB cosine theta. Okay. So let's try. A dot P, or D dot G in this case, is equal to 2 times 3, 2 times 3, plus minus 4 times 4, plus 1 times 10. What is this equal to? 0, right? So far, so good?
Yes.
Okay. So A dot P, which is equal to 0, is equal to what? We know A, B cosine some angle. Okay. We know A is not equal to 0 because this is A. We know B is not equal to 0 because, well, this is B. Okay, actually, let me rewrite it as D and G just so that it's clear. Okay. So the only thing possible to be 0 is cosine theta. And the only way for cosine theta to be 0 is for theta to be equal to 90 degrees. So we proved that these two are orthogonal.
يعني نثبت انها متعامدة صح؟
ايوه بالضبط. انت تعرف انه A is not 0 B is not 0 فبما
صح.
انه ال scalar product is 0 the only way for it to be 0 if they are at 90
على
degrees.
طول يعني. تمام. مشكور.
Okay, anything else? Uh, 90 why use dot vector not cross vector? Well, for one reason we haven't done cross vector yet, and two, remember the definition of cross vector was, oh, it's still presenting. Okay, remember the definition of cross vector. What was the definition of cross vector? The definition of cross vector was A cross B is AB sine theta, right? Sine 90 is 1. You will get AB sine theta and some angle, which is not very useful. Well, you can do it. I'm not saying you cannot do it. It's just more difficult. We will do, inshallah, cross product tomorrow. And who said that? Oh, okay. You yourself will understand. You will say, okay, I'm not doing cross product unless I absolutely have to. It's a pain. I don't want to do it. Okay. And also, it is usually easier. The dot product is easier. Also, you can easily find what the angle is. Now, if it's in two-dimensional, just I and j, cross product does just fine. But if you have ijk, it becomes more difficult. Also, one last thing, we will learn tomorrow that the cross product, one of the rules of cross products is that when you do A cross B, the result A cross B, actually we did this in the previous lecture. If we have two vectors, A cross B, the third vector is at 90 degrees to them. So it's not useful to find the third vector. We actually just want to know what is the angle between the two. Okay? Okay, it's 5 o'clock. That's all we have time for today. We started with about 80 people. We ended up with 34. So thank you for staying until the end. I hope it was useful. Yes, what's the problem with the lab?
With the lab assignment.
Yeah, what about it?
أنا رسلت له